Hello and welcome to 4 Sevens, a podcast hosted by Alex Box from mathsplay.org and Marissa Cashmore from Motivating All Maths Learners to Succeed. 4 Sevens is a 7-part series exploring and sharing different ways to learn maths through play.
The International Day of Maths is a global celebration of mathematics that falls on the 14th of March. In 2024, the theme will be Playing with Maths, and so we thought what better way to support this important theme by bringing together a range of maths teaching and learning professionals to share and discuss playful, positive and powerful ways to engage and connect with mathematics.
We hope that, when listening, you find the conversations valuable as we endeavour to inspire you with a range of stories, perspectives and many practical ways to explore and play with maths.
Before we get stuck into the episode, we'd like to acknowledge Aboriginal and Torres Strait Islander peoples as the traditional owners of the lands on which this podcast was created and is being listened to. We pay respect to elders past and present and recognise the contributions of all First Nations peoples to the land we live, learn and play on. In each episode, we approach the discussion like a hearty feast, an entree that shares a little of the featured person's story, the main course that delves deep into a topic, and an item from the dessert menu, a copy of which is linked to in the show notes. In this episode, we welcome featured guest David Butler to chat about playful and joyful mathematics. We hear about the community initiative he runs where people come together to play with maths, and we learn to play a fun game he created called Digit Disguises. We'd like to thank David once again for taking the time to share his experience and many practical insights and ideas. David Butler, who is, among many things, a mathematician and a maths educator, joins us for a chat today from the University of Adelaide. My understanding is that David's university study began with a maths degree, followed by a graduate diploma of education. Then, after some time working as a high school teacher, he went back to uni to do a PhD in finite geometry. It's a number of years later, David, and you now work full-time, I think, supporting students at the University of Adelaide with mathematics. Welcome to the 4 Sevens podcast, and thank you for being our featured guest for episode 1.
Well, thank you for asking me. I'm very excited.
Awesome. Marissa and I have been following you on social media for a number of years, and you share wonderful insights on maths teaching and learning. And with your permission, we'll be sure to add links to your blog and socials in the show notes. But in the spirit of our intended episode structure of the hearty meal, we'd love to start with a little getting to know you entree before getting stuck into the main topic. So can you tell us a little more about your day job and what led you there?
Well, I'm one of 2 lecturers in the Maths Learning Centre at the Uni of Adelaide, and the Maths Learning Centre exists to help all the students at the uni engage with maths wherever they meet it in whatever they're studying. And that could be logarithms turning up in a chemistry lab, or it could be statistics turning up in, well, insert whatever degree you've got. There's always statistics somewhere. Or reading a graph or a full-on pure maths course, all those things, it's our job. And I got into that because I worked at the MLC as a tutor back when I was doing my PhD, because they sort of headhunted me a bit because I had actual teacher training, which is rare at a university. And when the job came up, the lecturer job came up, I really wanted it very much. And so I remember crying after the interview at the thought that I might not get it. And so I got the job, and I've been doing that for nearly 16 years. It's my 16th anniversary in July. And I just really love talking to people about maths and learning, and I get to do that every day.
So with that, supporting people with maths as it comes out in their university studies, do you find many people coming into the centre that are holding common misconceptions from high school, for instance, and the need to correct those?
Yeah, there are actually. Sometimes they don't know that they're holding them. Like, they can just tell that they're not getting it right, but they don't know why. And sometimes they do know that there's something wrong with, and they want to fix it. I think one of the big misconceptions about mathematics that people have is that there is a way to do it, and the best way is to remember all of the procedures that go with all situations. And they think that the reason they can't do it is because no one told them. It's actually, well, no, you can figure it out. Yeah, but a lot of people just have patchy memories of mainly fractions.
Okay.
Yeah. They know they've seen it, they can't remember, and memory is the only thing they have because they haven't got the skills to figure it out. But I find that they do have more skills than they thought they did.
You just help them to dig those up and utilise them.
And sometimes just fill in the gap that's there. It's like, right, you just need to know this fact, and here it is. Yeah.
Wonderful. So it seems likely that many or most people who go on to study maths at university have enjoyed a lifelong love of maths. Was this the case for you? And can you pinpoint a key person or any experiences you think made maths so accessible and enjoyable for you personally?
I'm going to be a bit disappointing. I can't pinpoint it. So my mother has told me multiple times that I played letter and number games in my head from before I went to school. So evidence suggests I've always loved maths, but I have almost no memories of maths classes during my schooling at all. Now, partly that's related to my aphantasia and lack of sense of smell. I don't have a good memory, but partly it's, I think, just because it just never stood out to me as something that was either a problem or, sadly, particularly inspiring. But I must have enjoyed it because at the end of school, I wanted to go to uni and study a maths and science degree. But yeah, I just can't pinpoint anything. Like, remember some of my teachers, but no particular inspirations. Sorry, all of you. Yeah, but I can pinpoint the moment in my uni degree when I decided to study maths instead of physics. And it's probably an illustrative story.
Nice.
I was in a physics tutorial, and I had presented a solution to one of the problems, and I got told off because my solution was too clever. And I was a bit confused because it was the only solution I had thought of, so I didn't understand how it was too clever. They thought I was trying to be clever, but I was just like, this is the first thing I thought of. And I was angry because surely if a solution works and shows that you understand what's going on, it should be acceptable. So my experience in the maths tutorials was that multiple perspectives, like multiple approaches, were always acceptable and encouraged. And that wasn't my experience in the physics classes, and so I decided I would do maths instead of physics, which I think is interesting because a lot of people's experience of maths is not that's one of the same reason I stopped doing physics is the reason why other people stopped doing maths, is that the multiple approaches aren't honoured. So kudos to the tutors in my first year maths courses who really did encourage multiple approaches.
So I've been doing a bit of digging and having a look at your blog, and one of my favourite blogs was your the information and the explanation of 100 factorial that you have initiated. We'd like to know a little bit more about what is 100 factorial and why did it come about?
All right, well, you know the story then, Marissa, if you've read it, but I'm going to repeat it anyway. So 100 Factorial is the name of the regular art games puzzle session that I run at the University of Adelaide. And students and staff and sort of whoever happens to want to join in, like whoever's wandering through on the day or just random people, can join in and we all play together with mathsy things. So kinds of things we do is we have big versions of logic puzzles. So we'll draw a giant Sudoku on the board and we'll all do it together. We have construction toys and various games, and the numbers game that people might be familiar with from Countdown or Numbers and Letters, and all those sorts of things. And they're all out at once and people get to choose which one they want to do. And there's no particular plan. It's just what gets done on the day is based on the whims of me and my student volunteers who set it up on the day. and there's no curriculum per se. We just play with the things and then come back next week. And in the Anyone's Welcome yesterday, we had it all set up, and it happened to be the day that the Australian Youth Orchestra was on campus, and we were doing it during their lunchtime, and they all came and joined in.
Wow.
One of them was there last year at the same time and said, "Oh, last year you had the game set out. Do you have that?" I said, "Sure, I can go get it." And so it's really cool, actually. So it was I love 100 Factorial. So it's this little moment of joy in the week. So it started because while I was doing my PhD, I was asked to present to the students to convince them to keep studying maths. So students do maths in lots of degrees, and the School of Maths wanted people to keep doing the maths degree instead of switch over to engineering or something. So anyway, I did a talk, and I called it How to Tell If You're a Mathematician. And I have no memory whatsoever of any of the things I said. But I remember something that I did, which was before I started talking, I'd put up on the screen a puzzle. And I didn't mention it, I didn't point to it, I didn't look at it, and I did my talk. And at the end, I said, but the true way to know you're a mathematician is that you haven't listened to anything I've said, and you have instead been trying to do this puzzle. Cue guilty looks from all the math lecturers, which rather proved my point.
Love it.
Yeah. And that puzzle is called 100 Factorial. And so straight after that, when we went to the drinks and nibbles afterwards, we all stood around and we did the puzzle together, and I said, well, maybe we should just meet regularly and do puzzles, which we did. And then when I moved to the Maths Learning Centre, I brought it with me and been doing it ever since. And it is now called 100 Factorial after that first puzzle that was ever done at the session. Do you want to know what that puzzle is?
Awesome.
Yes, please.
Yes.
Okay. So the puzzle is any number factorial. You figure that out by multiplying all the numbers from there down to 1. So like 5 factorial is 5 times 4 times 3 times 2 times 1. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And so that's what factorial is. So 100 factorial is 100 times 99 times blah, 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 times 2 times 3 times 3 times 2 times 1. So if you figured out what that number was and wrote it out, how many zeros would be on the end? That's the question.
So you've got to be thinking about the 10. Oh, gosh. The tens and the multiples of tens and things like that, maybe? Or
possibly.
Okay.
That's a great first place to start.
All right.
Some people like to figure out the first few factorials and see if they can find a pattern to how many zeros there are.
Mm-hmm.
It's a really fun.
It makes me want to go and work on it.
Okay.
Yeah.
We'll have to wait till after the interview.
It's really inspiring to hear about the 100 Factorial, to the point where I was like, oh, how could we set that up in Melbourne? How many different sort of varieties of people do you get? Is it mainly people from uni, or is it others that come in as well?
So it is mainly people from the uni, so mainly students and mainly staff of the Maths Learning Centre, but some of the lecturers. We do it in a public place that's like a thoroughfare, so that people can just sort of wander past and join in for 10 minutes and then go when they're on the way from one place to another. So we do get whoever happens to be at uni that day. If there's a school excursion, we'll often try and get them to join in while they're coming past. But it has been really common to have people who are sort of know someone at the uni but aren't at uni to come before they come to uni, and they sort of get a taste of what that's like. That's really cool. And it's also a nice place where people who have left the uni and come back to visit, they know that they can meet us there at 100 Factorial. I will say there is a thing called Maths Jam, mainly for adults because they usually meet in a pub, but people meet together on, I think it's the third Tuesday of the month at a particular pub, and I think there's a couple in Melbourne actually, which is a similar vibe. But 100 Factorial is quite different because it has become sort of a public event rather than you sort of know when it's on and you come and, I mean, you know when it's on and you come and join in, but it's also part of the vibe is that we're doing something that looks interesting and people come over and join in, which is something I didn't plan it to be, but it became that way, and I'm really happy that it is. And so we have to choose activities that people can engage with without too much explanation. Yeah.
Yeah, sounds awesome. Can you tell us or talk to, and this is an extra question I threw in after reading some more of your blogs, the art in maths that you bring into that space, or when you have used art in maths to go nuts?
Well, my mathematical art is usually something that is collaborative, that people do together. And it's usually ephemeral. It usually washes away at some point. So one of the big ideas I have is that everyone can do maths, and that artistic expression is similar to mathematics in the sense that it's part of being human. And so I like to have things that people can be involved with. So one of the first art events I gave was My Piece of Pie, where we, on International Pie Approximation Day, the 22nd of July, we drew the digits of pi on the North Terrace main street of Adelaide footpath and asked people passing by to decorate them, and to just do that all day. And we got to 2012, we got to 1,000 digits. The point is that everyone got to decorate their own. That's their piece of pie. But the other mathematical art I do is more mathematical. So we've had random journeys where we got train tickets before we went to train card. We used to have little paper tickets, and I got people collected paper tickets, and then we have an artwork where you add paper tickets to it in whatever spot you like, but according to a particular rule. And so there's 4 panels, and each of them has been made slightly differently because it's random, and it's based on how people have decided where they wanted to put it at that time. And then we also have a big installation of a tessellation of silver rhombic dodecahedra, which you can make out of A4 paper origami. But in general, at every 100 factorial event, I will have something that is an artistic expression thing. So either a construction toy where you're building something. Yesterday we had pattern blocks. I'm sure you know what pattern blocks are, but the little coloured blocks of different shapes, and then an angled pair of mirrors, and you put the pattern blocks in the middle of them, and the mirror reflects around and makes it look like it's a snowflakey sort of thing. And so we have them out. So every week we'll choose a different thing that is more of an artistic expression thing for people to just fiddle with. Like when the aperiodic monotile was discovered last year, we made some copies of that and let people play with them. I just think that just fiddling with something until it looks nice to you is a completely different way of engaging with mathematics than other kinds of ways that people are familiar with.
You delivered a keynote at the Maths Association of Victoria's conference in December of 2017, so just over 6 years ago now.
I know, it's ridiculous.
Time flies when you're having maths fun.
Yeah.
And your keynote was called Playful and Joyful Maths. And just for the benefit of listeners, how would you describe, or what would you count as playful and joyful mathematics?
All right, well, I should probably say what I think play and joy are. So I define joy pretty much the same as C.S. Lewis, the author of the Chronicles of Narnia, defines it, which is happiness that nobody can take away from you. Because it belongs to you, but it's also at the same time bigger than you. So his example is like being inspired by a sunrise. That's a joyful experience because the experience is fully yours. It's your experience. It belongs to you. But the sunrise is something bigger than you that you are enjoying. And so that's the concept of joy. And maths is potentially full of those experiences. So figuring out that a maths fact has to be a certain way and it can't be any other way is similar. That experience of figuring out, that's your experience. It belongs to you. But the fact that that is true and will always be true, that's bigger than you. And so that's a joyful experience. So Even just noticing a pattern that you didn't notice before is a joyful experience, just a little mini bit of joy. So I guess you could say that a joyful maths experiences are ones that allow for that kind of wonder, but also that kind of ownership as well. And I'll probably talk more about that as we go. So I think everyone deserves to have joy. Like happiness and fun, they're different, they're related, but joy is something that is yours forever. So my definition of play, which I got from reading a whole lot of things, including Stuart Brown's book and Cassio Wedekind's keynote at some conference, and there's a few of them, but it is trying out ideas inspired by your curiosity. With a little addendum, it's like, and being absorbed in the experience.
Yes, like getting into that state of flow.
Yeah. Yeah, so you can really tell it's play when you're in that state of flow, but it's the trying things out inspired by your curiosity that is what creates the play. And so a playful maths experience is one where you're made curious and then you have ideas you want to try. And the try is really important. Like you don't necessarily know for sure how it's going to turn out when you try it because you're trying.
So there's that element of experimentation.
Yeah, and there's some unexpectedness that's going on.
Mm-hmm.
And so, there is a kind of play where you're doing something that's familiar to you and it's pleasurable, but that's not quite the same as this kind of play. So, yeah, you don't know how it's turned out, but you want to see. And so playfulness is much more about your approach than the task itself per se. It usually involves someone manipulating the edges of things to try and figure out where one idea ends and the next begins and figuring out what's possible. There are lots of things you can play with. I find it really hard to talk about exactly what a playful and joyful maths thing is, other than knowing that it's about that ability to give things a go and be curious. Yeah.
I get the sense too that be a lot about the feeling, the positive feelings, productive feelings, perhaps as well.
And the feeling of freedom.
Yes.
To try things.
Yeah. That concept of mathematical freedom is really interesting. That idea that that's a thing and to have it. Yeah.
And would you say like the vulnerability to make mistakes as well within that freedom?
Yeah, you're free to fail because it's not failing, because it's all part of the trying out.
So why do you think that, you did a keynote. Okay. So you did a keynote on this topic. So why do you think a dialogue about playful and joyful maths is so important?
Oh, man. Okay, so like play is how humans understand, and most animals as well. You understand things, like you get them inside you by trying them out to see where the edges are, to see what you can do and what you can't do and what you could do and what's true and what could be true. All of that is how understanding happens, and you do that by playing. So my argument is that anytime you have understood, even if you didn't notice it, you did play. So without play, people don't understand, and understanding is exactly what we want people to have in maths. We want them to understand. And that's not to mention the awesome experience that is joy. And maths is like inherently joyful because it has that opportunity for exploration. So there's like so many opportunities for ownership and wonder, and that means that maths could be and should be joyful. And so why wouldn't you take those opportunities to give joy to people's lives by doing maths? But the problem is, and the reason we have to talk about it, is that people don't do maths. Let's face it, a lot of school generally don't do maths in a way that allows for that ownership and wonder. And so we have to talk about it so that we don't lose it. and lose all these wonderful opportunities for people to have joyful experiences that they would otherwise lose. Life would be so much better if we let ourselves have those experiences.
One of the reasons that really one of the major reasons that we're creating this 7-part series is to try and unpack a little bit of what joyful and playful maths looks like and sounds like, because I think many people, like my former self, haven't really had that opportunity. So yeah, we need more people like you sharing in this wonderful way. And so with your keynote, I didn't attend. I don't think I went to math conferences for the first time till possibly the year after you presented. But I have gone through your slides, and it's really great to get you to chat to those a bit. In your presentation, you talked about play-like work and about finding the play in maths that at first looks like hard work or like the same old thing. Can you share with us what you mean by that, perhaps with an example?
Certainly. I'm going to start by saying what it's not.
Nice.
If that's okay.
Yeah.
So finding play in things is not putting a silly cartoon on your worksheet.
Yeah.
And it is not making each answer of your worksheet come out to a letter, and when you put the letters together, it spells out the punchline to a joke. The play that's in those things, if it is play at all, which is debatable, isn't connected to the maths at all. You're not playing with the maths, you're playing with something else. And the message I think it sends is that maths is so bad that the only way to make it palatable is to put silly jokes and cute cartoons on it. And it's not a bad thing to have cartoons, it's just that that's not what makes something playful.
Right.
And the other not is it's not putting your maths practice in a computer game where you try and score points for getting questions right. Now, that is a kind of play, but the thing they're playing with is the point system, not the maths. And to me, that's a key distinction that people don't realize, that people will play the game, and if the game is not a mathematical game, it just has math questions in it, then the play isn't coming from the math itself. So yeah, they're the knots. I just want to make them clear. Maths work that is play-like is maths work that has curiosity in it. So one of the classics is open middle problems, which you can Google, and the idea of the open middle as opposed to open-ended is that we know what the end is, but it's the middle that you get to do differently. So classic example is like you have 2 3-digit numbers and you have to choose the digits in such a way that the sum is as close as possible to 100. But all the digits have to be different to each other. And what happens when you attempt to answer a question like that is that you end up doing lots of addition practice. But as you're doing it, you're chasing that curiosity about a thing that is already mathematical. And you start thinking about closeness of numbers and all those sorts of things, but you're still practicing your addition. So you can make the act of practicing addition more playful by making it the thing that you'd use to do a different mathematical goal.
So it becomes authentic, that practice, in a way.
Yeah. So separately from that, rather than having a whole separate task, you can turn a list of exercises to be more playful by making the goal curiosity rather than the goal finishing the exercises. So instead of the instructions being do all the ones in the left-hand column, which is classic, it can be do problems from the list until you notice something you're curious about and then investigate that.
Nice.
Because what happens, and I notice when people do exercises or they do online quizzes, is they go, oh, cool, it's correct, and they move on and they don't stop and think about anything that's happening. All they thought about was whether they were right or not. But if the goal is curiosity, to say, keep going until you notice something, maybe about how similar and different the different problems are to each other, or about whether it's even possible to do it if the number is this kind of number, or whatever. And you may have to give your students some examples of the kinds of things by you doing that. But if the goal is to find something to be curious about, then that completely changes it to be more playful. So getting stuff done is a kind of play, but not everyone plays that way all the time.
I am curious to find out why you think people do find it hard to see the joy side of maths, and if you have found anything useful to change this.
Yeah. It's one of the greatest tragedies that people can come through school, and not just maths, pick any topic, and hate it. Like, I wouldn't want people to come out of school hating anything. They could decide that they don't feel like doing it most of the time, but that's a different thing. So, like, if joy really is to do with an experience of belonging, and an experience of being part of something bigger, then I reckon missing out on joy is a lack of belonging and or a lack of wonder. Look, humans are mathematical beings. They have mathematical thoughts. And most of the time, it's not that hard to talk to someone for very long until you find something that's truly awesome in their mathematical thinking. But what happens is they get told that what their mathematical thoughts are is not the right way, or it just gets completely ignored. That's just ignored wholly because it's not the way the teacher wants right now. And I understand how difficult the job of teaching is, especially when you feel like you've got to get through everything. But it's a surefire way to kill the feeling that maths belongs to you by ignoring or discounting people's mathematical thinking. So it just makes me tear up. It's just the saddest thing. And we do it so often without even realizing we're doing it. So one of the things you can do to change this is to really listen to the mathematical thoughts that your people you're with and your students or your friends or whatever already have, and point them out. So one of the reasons we do mathematical art is that people don't see it as maths, and we can say, look, that thing you did so well, that is maths. And it's the same thing people do when they do this thing, which you do see as maths. And so, listen to their thoughts. So giving your teachers and friends opportunities to tell you what they're thinking and really listening to what they say, not waiting for a particular answer, but listening literally to the thing that they say and then celebrating their thinking is the most important thing you can do. If you're a school teacher, across the year, every one of your students has to have had their mathematical thinking acknowledged and celebrated at least once. And that's the bare minimum. So it's so easy for us as teachers to not listen to the students, but just be listening for particular things. Most people who describe the experience of teaching as a positive experience talk about learning things from their students. You can learn that there's a lot more maths in there than you thought, and so can they. So that's one place with the joy, and that's where you can deal with the belonging to you part of the joy. And the other thing that saps the joy out of maths is relentless exercises and the focus on being a good machine that churns out calculations. Some people can be encouraged to play with their own skill and to be curious about how fast or how accurate they can be. It's the same thing that people play with when they're a solo athlete, like a runner. That's a kind of play, to be better. But most people need more chances to wonder about things than just their own skill. And so, because otherwise it feels too much like work. And so if you're trying to change it now for someone after school is over, then you can give them things to do that aren't exercises, that allow for the freedom to be wrong and trying things out and still be doing it right by doing it wrong. So things like puzzles and toys and whatever are good things. Or just listen to them to say, oh, well, what things do you like to do? And listen to them talking about it and saying, oh, that bit where you noticed that there was a difference between these two different kinds of wine, and you therefore went to learn about what distinguishes between them and how it makes it better and worse. That's mathematical thinking. That's the same thinking that if you wanted to, but you don't have to, but if you wanted to, you could apply to the multiplication table. So there you go. I think about this a lot.
From wine to the multiplication table. Love it.
Yeah.
Beautiful.
Yeah.
I was involved in the running of an online maths teacher circle a few Januaries ago now, and I remember being in awe of a game you shared that you'd created called Digit Disguises.
Yeah.
And I don't remember how to play, but I do remember it being really fun and involving algebra and being really impressed by the fact that I was playing with algebra and having a good time. And I also remember that it was a game that could be adapted to a wide range of ages.
Yeah.
So I wondered if that was a game that maybe you could explain for us now.
Sure. What I might do is I might introduce it the way I would normally introduce it to a group of people. And I've put a link to the blog post where I talk about that.
Nice.
In the notes. So the goal of the game, it's called Digit Disguises because we have the digits, like the numbers from 0 to 10, 0 to 9, and they're in disguise as letters. They've gone to a dress-up party and they have dressed up as letters today. And that's how the game works. And it's a bit like Battleships, usually, when we play it, where one team, they've disguised their numbers as letters and the other teams disguise their numbers as different letters, and each team has to try and figure out which letter goes with which number. But you can also play it mastermind style, where one person knows and everyone else is trying to guess. And that's how we're going to play it here. So one of you is going to be the person who knows. Which of them would like to be the person who knows what letter is what number?
Do you want to keep track of that, Marissa?
Yeah, sure. I can do that.
So, Marissa, we're going to play a small game of digit disguises. And what you're going to do is you are going to disguise the numbers 1 to 4, like 1, 2, 3, 4, as the letters A, B, C, D. So you'll say, for example, you might say 1 is A and 2 is D and that sort of thing. So you're going to write that down somewhere. Numbers 1, 2, 3, 4, and they're going to be given the letters A, B, C, D. Cool. And you're going to be the person who knows that information. And we're going to try and figure out which letter goes with which number. And the rules of the game are that we can ask you any question of the type letter, plus, minus, times, or divide, different letter. Mm-hmm. So don't respond to this question yet, but I'm going to start by saying A plus B. You are not going to tell us what number that is. You are going to tell us which of the 4 letters you have that answer is. No one is ever going to say a number in this game until the very end. So I might say A plus B, and you will tell us which letter that is. Which letter is it?
C.
A plus B is C. I better write that down somewhere.
Me too.
Okay. Marissa, do you have a question about what might happen when I ask something like A plus B?
Not really.
Alex?
Well, I'm wondering if the answer to A plus B could be more than 4 and therefore not answerable.
Yes, so that is true. And if that does happen, Marissa, if we ask for a calculation and the answer isn't one of the numbers you've got, you'll just say, that's not one of my letters.
Okay.
Okay. Well, Alex, what information have we got, knowing that A plus B is equal to C?
Well, we know that A and B are smaller than C.
Mm-hmm.
We know that C is either 3 or 4.
Yeah, because it's got 2 numbers that are smaller than it.
It must be 3 because we don't have 2 plus 2 as an option, I think.
It could be, A plus B could be 1 plus 3 and C could be 4.
1 plus 3. That's right. Okay.
Oh, yep. Okay, cool. So what question would you like to ask now of Marissa? Okay, what calculation are you going to ask Marissa?
I want to know about D. So I'm going to ask, well, have a go. What's D take away A? Can I ask that?
Yep.
D minus A.
It's not one of my letters.
So I've written down D minus A equals not a letter. What does that mean?
So I think it means that D is not, it's not going to be 3 or 4 because oh no, I'm confused.
I have a different thought. If when you do D minus A, you don't get one of the numbers 1, 2, 3, 4, that would have to mean that A is more than D.
Of course.
And so if A and B are both less than C, and D is also less than A, then all 3 of A, B, and D are all less than C.
Yes.
And so C must be 4.
Yeah. Okay.
Not that we're allowed to ask Marissa if C is 4, but now we know what C is, we might be able to start figuring out what the other ones are. I'm going to stop there. What are your feelings about this game?
Well, I remember, I think we played a larger scale or something.
Yeah. So the traditional game is the numbers from 0 to 9.
Okay. And what I love about this, first of all, is the scope for experimentation and not knowing. So there's an even playing field. No one knows anything at the start. And by design, we need to do some experimentation and some thinking, and we're going to struggle. And it's fun. I just love the little hook at the start, that context of imagining being dressed up in disguise. And it's going to take some time to play and wrestle with. We're not done.
I love how much it challenged me and made me think. And even about your discussion, like I was like, okay.
And you have it from the other side where you know what the numbers are. So you have a whole different perspective on what's going on here.
But I like the fact that you asked me what questions I might ask, because I didn't have many at the beginning, but I sort of do now. Yeah, as the game goes on. And with that, the fact that you're asking us for our questions, and you know that we will inevitably have some, and that invitation of our questions as part of that reasoning and thinking and learning process.
And another thing I want to point out to everyone who's listening is that we've learned some things without even finishing this game. You do not have to finish an activity to learn something. And it is, in fact, a really useful strategy to stop people before they've finished things, to ask them what they've learned or what they've figured out so far. Yeah, so it's one of the reasons to play a small game before you set everyone out. So normally at this point in a large group, I would give everyone the traditional game and put them into teams of 2 that are each playing against each other, battleship style. And just to add to the final rule is that, like, at any point in the game, you can say, if you would like to know, if you think you know what all the letters stand for, you can say, I think A is this, and B is this, and C is this, and D is this. And if you're right, then you win. And if you're wrong, then you lose. So you can only do it once. But you can change that rule if you want. But that's the traditional rule. You only say a number once in the game, at which point you say all the numbers. So, yeah.
Thank you for indulging us with that.
It's all
I
good.
was really eager to play and relive that experience. So we'd love to learn as much as we can from you, and wondered if you could share any specific example or anecdote from your experience where playful maths had a positive impact on student learning of maths.
I'm going to give you my biggest example, which is when my daughter was in year 6, her teacher let me take an entire school day, take the class for a whole day. She was there, but take the class for a whole day to just do maths.
Oh, wow.
And so we did quarter the cross, and we did the 0 zeros problem. I'll send you a link to the blog post I wrote about that day. A puzzle called Spotless Dice, and we looked at some maths art, and then I read a Hotel Infinity story aloud to them. And the best quote, so then the teacher did an exit ticket sort of thing where she asked the students to write about, how they feel about maths. And the best one is, I like maths a lot better now. Before it was like, get me out of here, but now it's like, can we keep going?
Oh.
So that day I chose those activities especially to try and show that there's different maths things and that you can interact it in different ways, but also to try and give as many opportunities as I could to notice when the kids were doing something that was good mathematical thinking and point it out. And I've learned so much more that day in particular, but I've learned so much more about that aspect of working as a guest in someone else's class, or when kids coming to the uni to do a maths activity, or even just everyday teaching. It's like the most opportunities you can have to just point out when they are doing mathematical thinking, because they may not realize what counts as mathematical thinking, and to give them success. And so that's my best example of any of that it was all playful, but all different kinds of play. But on a much, much smaller scale. It's really useful to be playful with the tools you use to make sense of maths. Like in my Maths Learning Centre, I've got a big graph on the floor, and I've got Play-Doh and lots of coloured paper and string and those sorts of things. It's really useful to sometimes just pull out the Play-Doh and make a model of the thing to support their imagination. Especially at the university, they're doing multivariable calculus in second year of uni. They're trying to think about 3D objects, and they just don't have the imagination yet. And so you can make the object. And it breaks them out of the staring at the page. Like, people have this feeling that maths is all like on a piece of paper, but breaking them off the page and using a different way of understanding is a playful thing to do, to say, well, what I'm going to play with now is I'm going to explore how to think about this in a different mode. And so that's a really useful thing to have in the back of your mind, to say, well, maybe I'm just going to do a different way today. So you're exploring an idea in a new way, and that's why it feels playful, because you're not trying out a new idea, you're trying out a new way of thinking about the idea. Students get into this thought paralysis. They stare at the page and they don't know what to do, so you just do something else. And on an even smaller scale, students are doing their online assignments. There are times when they're asked to enter not one particular answer, but an example like. So this is good writing on the behalf of the people who write these assignments. It's like, enter a number A such that this formula is a hyperbola, something like that. And then they do it and they get the green tick and they move on and they don't stop to think about it. And so I'll turn it playful with saying, well, what other numbers would have worked in that spot? And it's my favorite thing is when they notice that any number above 5 would work, and they go, really, any number above 5? And then they put in 10,000 to see if it would work, and it does. And that's play. But what that does is it makes them stop to think about it for a bit, but also gives them that little buzz of, I had an idea and I tried it and it worked. And I'm sort of cheating the system by putting in a giant number, and so it's all of that.
Great examples. Gosh, I'd love to have you in my class for a day, David. What a gift.
That was one of my most treasured experiences, doing that.
How wonderful. Well, just wondering if there are any particular activities or games, and you have mentioned a few already, so all good if not, but are there any that you've found to be especially effective for teaching tricky concepts?
Oh, it is tricky, right? Oh, this is really interesting, because games, it's not usually the game itself per se that teaches the concept. Sometimes it might teach a generic lesson, like the importance of trying things out, or of perseverance, or of generally being logical. It doesn't teach algebra per se. And it might give them a chance to practice a skill in a new way, like prime climb, for example. This is practicing the skill of calculations in a new way. But my favorite thing is when games give you like a touchstone experience to use as your example in your later explicit teaching. So, for example, digit disguises, they've got this experience, and then later you can introduce the concept of algebra and say, hey, you were doing it already. Look at it. Yay. And algebra isn't really about figuring out what numbers are. It's about noticing how numbers behave and what you know about them from the information you've got. And so digit disguises can do that. And I use digit disguises with my second year pure math students. When they start to study pure algebra, where you may never know what the numbers are, but you can notice how they behave. And so you might be in a whole new place where the numbers don't even have the same names, but you know that this number is just like the number 0 is, because when I add it, nothing happens. And so even if it's not called 0 today, I can call it 0. And so this is the game gives you that touchstone experience to say what you're doing here is not different from the game. So my example of that, a specific example, is that I did a seminar on linear regression in statistics. And I started it by playing a game of Guess My Rule, which goes, I have a secret rule for calculating. Students give me numbers, and then I calculate and give them the answers. And they have to guess what the rule is. And so I play a couple of times. And then in the third or fourth one, I make the rule, and they don't know I'm doing this because I'm doing it on the computer. I make the rule like, times 10 and then add whatever number my dice tells me. And so up to now, it's just been a straight up calculation. And it's a real moment of surprise. And I can come back to that experience of there's a bit of randomness involved to help them make sense of how linear regression equations work, saying, and there's this random bit. There's this bit that's a calculation, and there's this random bit that you'll never know, and that's why we need statistics. And because they're relating it to a game, it's this shared experience they can use as a touchstone to make sense of it. Whereas if I try to relate it to real world things, it doesn't hit them all because people have different experiences, but the game can be a shared experience that they can all know that they all have had that experience, and they can use it as a way to make sense of something new.
So having that balance, the balance of different experiences that are going to complement each other. And
yeah. So without the game, the explanations in the explicit part of the teaching wouldn't have made as much sense. And I warned them at the beginning, like, I'm going to play this game. It's going to be something that we're going to be able to use as an example. So just bear with me, because some people at university really don't like to do primary school things.
Hey, I'm offended by that as a primary teacher. No,
I'm offended by it. Whenever anyone has said that, I've been deeply offended to say, stop it. Kindergarten's the best year of your formal schooling.
Oh, that is a really great explanation. I love that sort of zooming out and seeing how the games work with the explicit teaching and other things. So as educators, I think the language and the behaviour we model doesn't go unnoticed. I wondered if there are any simple things that we can say or do to help paint mathematics in positive and playful ways, even if we ourselves have not yet had really rich opportunities to develop a truly deep love of mathematics.
I'm going to harp back to some things I've said before. I think the most impactful thing you can do is actually listen to the kids' thinking and celebrate their mathematical thoughts they already have. That will help make something that belongs to them, which is part of the experience of joy. So we worry a lot as teachers about the things that we say, but we don't worry as much about what they say. And I think that's where one of the key points is. Like, whenever a student says an answer, whether it's wrong or whether it's right, you ask them, how did you think about that? And then find whatever cool maths thinking they say, which is guaranteed to be there. So just add it to your list of things to say and practice asking their thinking and then finding something to celebrate. And that seems a bit twee, but yeah, you just can't underestimate how good it is for you as a teacher to notice the brilliant thoughts your own kids have, especially the ones that are struggling. Struggling students usually have the best questions, and treat their questions as evidence of mathematical thought. And so the other thing you can do is when you're doing maths presenting maths, is to add the phrases "I wonder" and "what would happen if." Even if you don't get your students to respond to those wonderings, you can do it, and they can see what happens when you say those things, because they are the great starters for mathematical, playful thinking. And I do it in my seminars with the students. They're studying for their exams, but I still do it and say, I wonder what would have happened if that was a negative number. Now, you wouldn't necessarily do that with your primary school kids, but you might. I wonder if I knew that one and not that one. Or I wonder if this was written backwards. Anything. Give yourself a little bit of extra space every so often to add an I wonder and then make time for what comes afterwards. Or when you're with students and they're working on things and they're all very happy with what they've got, and you say, I notice that these two questions are the same except for that number. What happened, with the answers? So those are the sorts of things that I want them to notice when they're doing their examples, when they're exercises, so you can do it too when you're doing things. So add a few I wonders every so often is what I would say if you're going to have a simple thing to change. I'm sure there are others, but it's a start.
Two things that I love about that example, and it's so simple to implement, is that as the teacher, you don't actually need to know everything. You can purely model wondering, and that's quite easy to do. Another thing that I love about that mechanism is it does provoke thinking and curiosity, probably in the audience and the listeners, without placing an expectation to have an idea to contribute. Something that I've noticed is that we're often asking a lot of questions and wanting kids to think about them and eventually, have some responses to share. But creating that space to just purely wonder and invite a little bit of thought without that expectation feels like it could be quite transformative if it was something that we were doing regularly in the space. So thank you for that.
You're welcome.
We have a dessert menu, and one of the items which I think you want to respond to, David, is the one around play personalities or favourite ways to play. And you and I have both read the book by Stuart Brown. I think it's Play, how it opens up something, invigorates the soul.
Yeah, shapes the brain or something.
Yeah, I'll link to that as well. It's a fabulous book, and it really transformed my perception about everyday work and life and well-being and play and its importance for people of all ages, including adults. But one of the things he presents in the book is 8 preferred ways of playing. He refers to them as play personalities, but they've got the artist creator, people who love collecting things, the competitor, the director, the explorer, the joker, the kinesthete, so people who love to play by moving their bodies, and the storyteller. And of course, you can have multiple favourite ways to play. What's your favourite way to play, and can you share something about that with us?
And I'm going to subvert that a little bit.
Beautiful.
I just want to say the play personalities remind me a little bit of learning styles, in that it's clear that people do have preferences, but they're not fixed for a particular person across all situations, across all time. And as you said, because that's one of the fallacies people have about learning styles. It's not like people don't have preferences. It's just that you don't have ones that are fixed. And so you might play differently in a different situation or play in several different ways simultaneously. Like, for example, a joke is a kind of story, and so your joker is also a storyteller. One of the things when I read this, I went, okay, well, that's interesting. But when I thought about it more, it was much more effective than his properties of play at helping me realize that there are more ways to play. So he had his properties of play of purposelessness and the flow thing about the absence of time and the forgetfulness of self and those things. And it's very sad that mathematics, the first two, like purposelessness and voluntariness, we completely destroy those in maths teaching at school, because we go on and on and on about how useful maths is and how important it is. And we just make people study it. And so it's like we've completely destroyed two of the aspects of play. Anyway, that's but the play personalities really made it possible for me to see that people play in multiple different ways, even ways that to me sound like work. Not that work can't be playful, but they just sound not fun. And I want to talk about that, not with maths, but about board games. So I love board and card games. People say to me, "Is this a maths game?" I say, all games are maths games. Yeah. But I really love board and card games, and I recently have become a lot aware of the different ways I play with games that are rather interesting to me. So the obvious way to play with games, give anyone a game and they say, how would you play with this? The obvious one that they would probably say is the competitor. They'd compete, because there is literally a description of how to win a game. And so to beat everyone else and be the winner. But strangely, this is not at all a natural way for me to play games. I've never cared about winning. It just makes me feel bad most of the time. Like, it feels very much like work. And it's not like I don't try to win, because that's how the game works, but it's not important to me, winning. And I used to get really stressed out playing with really competitive people. It's like, what is wrong with you? And what I discovered reading Brown's book is that a competitor is also playing. Whereas to me, competition doesn't feel like play. And to a competitor, the other people in the game are not different to the cards and the dice. They are just components in the game. So a competitor is trying to win the game, and the game involves other people, but they are just part of the game. And so it's not personal to you. They're not trying to beat you. They're just trying to beat everyone. They're just trying to beat the game, and you are part of the game. And so that made me have a lot more grace for people who are really competitive. And it gave me the freedom to let them focus on winning, and I could focus on something else. I didn't have to worry about someone winning, because they would. And so, they can propel the game forward by trying to win, and I can focus on a different way to play. And I think that's a useful thing in lots of circumstances. And in maths class, one of the ways that people recognize to play with maths is to play with your own ability and to be a competitor. But I don't think there are many people who are competitors naturally in situations that aren't sport. But some people are competitive with just a few things, and other things they're not. And so no one's a competitor all the time, I don't think. It's situational. But some people gravitate towards things because they like that. But yeah, anyway. So that means that for two things, for people who are competitors, they can turn maths into a game that they can win, and therefore make it more playful that way. But everyone else can say, I choose not to compete. I am going to not worry about winning, but worry about something else. And his play personalities means that you can pick something to worry about. So just to go back to the games, I'm going to finish it. I like playing board games as a collector, a director, a storyteller, and an explorer. So I really love learning new games. In general, I would much prefer to play a new game I've never played than an old one I played before. I like to collect games with interesting mechanics or interesting art, or with concepts that intrigue me, or where the players interact in interesting new ways. I love collecting new games. And so as a meta thing, like above the games, I like collecting new ones. So I like playing new ones and watching what happens. And I only realized that recently about myself. And so when I play a game, I can forget about winning and just experience this new experience that I haven't had before, like the the collector who likes collecting new travel experiences, for example. Yeah, and when I do play a game, if I'm playing a new game, I usually take the role of the director and I help everyone interact with each other and with the game. And I really love doing that. I mean, I wouldn't if the teacher in me is a little bit like that, but I love playing as the director, and I have no caring whatsoever about. I sometimes even forget to have my turn because I'm focusing what everyone else is doing. But when I play a game that I know and other people don't, I'm in the storyteller role, and I try and find a really good way of explaining how the game works. And then finally, sometimes I'm the creator. I love to make my own games, but also, I'll modify the existing game, or I'll go, that rule doesn't work. I'll try a different rule, and we'll see how it works. And then I'm always the explorer. It's like, oh, what's happening? How do people interact? Oh, that's an interesting idea. So games tell me that I'm multiple different ways of playing, sometimes simultaneously, and sometimes different situations make me play different ways. And it's a useful, really way to think about trying to apply that to other parts of your life. And if you don't like how something is, you can choose to play it a different way. I think that's a big lesson for maths class. If you're a student, you don't have control over it. You can have control about how you play the game. Yeah. So there you go. That's my dessert.
Wonderful. We do have a sign-off question now for you, which is, what does 4 sevens make you think of, or what's your favourite way to solve 4 times 7?
Well, 4 sevens makes me think of 4 collections of 7 things, and the picture that's appearing is they're arranged in like a star. There's like 4 here and 4, like 7 here and 7 here and 7 here and 7 here. But they're not like in a line. It's like, I don't know, there's a clump of 7 over here in some sort of arrangement. And if I built it myself, it would look prettier than just 4 lines. That's what happens in my head when I think of 4 sevens. I don't know if I have a favorite way, but the way I'm thinking of today is that 7 is 5 plus 2. And so 4 sevens is 4 fives, which is 20, and 4 twos, which is 8. And so it's 28.
Oh, that's nice. We haven't had that one.
But the other one that I already said earlier, it's like, well, we've got 2 sevens is 14, and then 4 sevens would be 2 lots of 2 sevens, and so that would be 2 lots of 14, which is 28. But the 7 being 5 plus 2, 10-framey, is how I was thinking of it.
Nice. We're going to have to visualise everyone's at the end of the series, I think.
Draw them up.
Yeah. Well, thank you so much for joining us for what's been an excellent feast of discussion.
Yeah, thanks for being our first ever guest on our podcast. You've been amazing.
Oh, you're most welcome. Yeah. Thank you for asking me. It's very exciting. I want to hear all the other ones now. We hope you enjoyed this episode of 4 Sevens. To access any of the resources mentioned in this episode, you can find links to these in the show notes. If you know someone you think would be interested in this episode, please remember to play it forward to them.
4 Sevens is produced by Maths Play and is a partnership project between Maths Play and motivating all maths learners to succeed. If you'd like to send us a message, you can do so at mathsplay.org/podcast.